Lisp stands as one of the oldest and most influential programming languages in computer science history, often reverently called God's programming language. This title is not given lightly, but earned through its profound impact on programming paradigms and computer science theory. Created in 1958 by John McCarthy at MIT, Lisp, which stands for Lisp Processing, emerged as the second high-level programming language after Fortran. What made Lisp revolutionary was its foundation in lambda calculus, a mathematical formalism for expressing computation based on function abstraction and application. The most distinctive feature of Lisp is its syntax based on S expressions, where both code and data share the same representation as nested lists enclosed in parentheses. This property, known as homoeconicity, means that Lisp code can treat other Lisp code as data, manipulating and generating it programmatically. This concept gave birth to the idea that code and data could be interchangeable, a principle that fundamentally changed how programmers thought about software. Lisp introduced numerous concepts that were decades ahead of their time. It pioneered garbage collection, eliminating the need for manual memory management. It brought dynamic typing to programming when most languages were statically typed. Perhaps most significantly, Lisp introduced functional programming to the world, emphasizing immutable data and first-class functions. The language also gave us conditional expressions, recursive function definitions, and symbolic computation capabilities that were unprecedented. These features made Lisp particularly well-suited for artificial intelligence research, which is why it became the dominant language in AI for decades. What truly elevates Lisp to its divine status is its ability to redefine itself. Through its macro system, Lisp allows programmers to extend the language, essentially creating domain-specific languages within Lisp itself. This extensibility means that Lisp can evolve to solve problems in ways its original creators never imagined. The influence of Lisp extends far beyond its direct usage. Modern languages like Python, JavaScript, and Ruby have adopted functional programming concepts that Lisp pioneered. Features like list comprehensions, anonymous functions, and higher-order functions all trace their lineage back to Lisp. Even today, dialects of Lisp such as Common Lisp, Scheme, and Clojure continue to be used in production environments. Clojure, running on the Java virtual machine, has brought Lisp's powerful concepts to enterprise environments. Emacs, one of the most enduring text editors, is largely written in and extensible through Emacs Lisp. The elegance of Lisp lies in its simplicity. The entire language can be defined in terms of a small set of primitive operators and a simple evaluation rule. This mathematical purity, combined with its practical power, is why computer scientist Alan Kay famously stated that Lisp is the Maxwell's equations of software. Lisp represents a unique convergence of mathematical elegance and practical utility. Its influence on programming language design, artificial intelligence, and computer science theory has been immeasurable. While not the most widely used language today, its ideas permeate modern computing. The title God's programming language reflects not just Lisp's age or influence, but its transcendent quality, a language that revealed fundamental truths about computation itself. In the cathedral of computer science, Lisp remains the language that most closely approaches programming divinity.